What if we could create life? No, not in a lab with test tubes, but right inside a computer, using nothing but code. Today, we're diving into the blueprint for something called Sim Agent, a project that is literally trying to build a digital organism from the ground up. And we're going to kick things off with a question that sounds like it's straight out of science fiction. Can a computer program actually dream? Stick with me, because the answer might just surprise you, and it's right at the heart of what makes this whole project so revolutionary.
So, what's the big idea here? Look, this isn't just about making another AI that's good at chess or can paint a pretty picture. No, the ambition here is way, way bigger. It's about developing a true digital organism, a working prototype for an entirely new form of artificial life.
At its core, a sim agent is designed to function a lot like a living creature. It has internal needs it has to take care of, it can actually perceive the world around it, and, this is the crucial part, it learns to adapt its behavior so it can survive. It's this self-contained little system, modeled on the basic fundamentals of life itself.
Okay, so how does this whole thing actually work under the hood? To really get it, we need to break down the anatomy of a sim agent. You can kind of think of it like we're mapping out the biological systems of some newly discovered species.
Every single sim agent is built from 5 core components, and they all pretty much mirror biological life. It's got a biology to manage its internal state, senses to see the world, a brain to process everything, a motivation system to give it drive, and of course, a set of basic needs it has to fulfill just to keep going.
First up, we've got its biology, which is handled by a module they call the LifeManager. This is basically the sim agent's internal life support. It's constantly keeping track of vitals like hunger, its energy levels, even its mood, all to keep the organism stable and balanced.
So how does it see its world? Well, its senses come from a component called the MultiRayDetector. It acts like a set of virtual eyes, shooting out these digital rays to identify objects around it, whether that's food, a bed to rest in, or just an obstacle in its way. This is how it literally builds a map of its reality.
Now, all that sensory information has to go somewhere, right? That's where the brain interface comes in. This thing is the sim agent's central nervous system. It takes all the signals from its biology and its senses and feeds them to the AI models that make the final call. It's the critical link between just perceiving something and actually doing something about it.
But what makes it want to do anything in the first place? Well, that's the job of the reward designer sim. You can think of this as its motivation center, its sense of pleasure and pain. It gives the sim agent a positive score for good actions, like eating when it's hungry, and a negative one for bad actions. This simple reward system is the absolute foundation of its ability to learn. And what's really fascinating is how these needs are measured. As you can see here, each one is on a really simple scale. For example, for hunger, 0 means you're full and 1 means you're starving. And here's the kicker. Over time, these values naturally go down, which creates this constant pressure for the sim to do something. It has to act to restore that balance, just like any living thing driven by instinct.
So, we've got all the individual parts, biology, senses, a brain, and motivation. But how do they all work together? This is where the magic really happens, where we see this dynamic cycle of learning come to life. The sim agent's entire existence is just this constant 5-step loop. First, it observes its internal state. Something like, hey, my hunger level is getting pretty high. That data gets transmitted to its brain, which then decides on an action like, okay, time to find some food. Then the sim acts, and finally, based on how that goes, it gets a reward or a penalty, which reinforces whether that was a good idea or not. This loop just runs over and over and over again, creating this perpetual learning cycle.
And this is the most important takeaway here. The sim agent isn't trying to win a game or get a high score. Its one and only purpose is to maintain its own internal stability, to keep all those needs in a healthy balance. In other words, its primary drive is, quite simply, survival. And this brings us right back to that wild question we started with, because to learn efficiently, the sim agent does something truly remarkable. When it goes to sleep, it doesn't just power down. No, it enters a dream cycle. And what's wild is that the function of this dream cycle is incredibly similar to human sleep. Just like our brains consolidate memories and process the day's events overnight, the sim agent uses this time to reevaluate its past actions. It reinforces the things that worked, it learns to forget the things that didn't, and it clears out its short-term memory to get ready for the next day.
In essence, this dreaming allows the sim agent to learn offline. It can replay events, analyze its choices, and fine-tune its strategies without any real-world risk. It's an unbelievably efficient way to get smarter. So, can a computer program dream? In this very real, functional sense, yeah, it can.
Now, this is all fascinating for a single agent, but why does this really matter in the grand scheme of things? Because building one digital organism is just the first step. The ultimate goal here is to lay the foundation for entire digital ecosystems.
The project's vision statement really just says it all. The goal is to create a true, logical organism that can do everything we associate with basic life. It perceives, it learns, it dreams, it forgets, it regulates itself, and it adapts. This sim agent is just the very first seed.
And that leaves us with a final mind-bending question. We've just explored how one of these digital beings lives, learns, and dreams all on its own. But what happens when you put hundreds or maybe thousands of them together in the same world? What happens when these digital organisms start to interact with each other, to compete, and maybe even cooperate? That is the new frontier. This amazing blueprint for life is just beginning to open up.